Today topic is data link layer. So here we are going to see the introduction about data link layer. So it is a well defined service interface to the network layer is called as a data link layer. And we are going for a functions. So we are having 5 types of functions in data link layer. First thing, flow control. Second one is error control. Third one is error detection, and fourth one is frame formatting, and then last one is sequencing. So first thing, flow control. Flow control means point to point connection. So point to point connection means one node is connected with the another node is called as a point to point connection. And then we are going for a error control. We are seeing a error detection as well as retransmission also. So in this, if the error will be detected and then it can be find out, and then we are going to retransmit the data again. That is comes under a error control. And we are going for a error detection. We are identifying only the error. It comes under a error detection. So we can't able to do any corrections here, just we are going for a control only. So just sorry, we are going to detect only, so that is comes under a error detection. And then next we are going for a frame formatting. So both source and destination address will be added in the frame, that is header and then trailer will be added in the frame is called as a frame formatting. And then last one is sequencing. So sequencing means the order of updates to ensure that the successful message or unsuccessful message, that is comes under a sequencing. So in this 5 types, the error detection is plays a vital role in designing data link layer. Why because means it can be identifying the errors by using some types. So already we have discussed about VRC, LRC, CRC and checksum. So that is comes under a error detection types. And then next we are going for a service provided to the data link layer. So it is the responsibility of data link layer is to provide service to the network layer, that is source to destination. Service is transferring the data. Source is a one node and then destination is the one node. In between the service is transferring some data is called as a service provided to the network layer. In this we are going to see first one is acknowledged connectionless service. So in acknowledged connectionless service, we are going to see, as name suggests, that it is unacknowledged form of transmission. So here the source machine sends the data to the destination machine without any acknowledgement. So for this, no connection is either established or released. So if the data is lost due to noise or interference, the lost data is not even recorded by the layer. That is comes under a unacknowledged connectionless service. And the next one we are going for a acknowledged connectionless service. So in this service, each data frame is acknowledged by the destination machine. So if any data frame is lost or not arrived in time, the same can be transmitted again, and then in this service no connection are used. And then third one is acknowledged connection service. So in this the service establish a connection prior to the data transmission, and each frame is numbered before transmission and corresponding acknowledgement is also received. So the transmission is carried out in distinct phases. So in short form we can tell that in unacknowledged connectionless service, server is going to send the message with no acknowledgement, and the destination, in destination side, it will be received without any acknowledgement. If the data is lost, we can't able to recover. And then in acknowledged connectionless service, server is going to send the data to the destination, and then it will be acknowledged. If suppose the data will be lost means it will be retransmitted. And then acknowledged connection service means source is going to send the message to the destination, and then connection established clearly, each frame is numbered and acknowledgements also required. Next topic is framing. So in framing, we are going to see how the data link layer separate a message from one source to a destination. That is by adding a sender address and a destination address. So in this, to service the network layer, data link layer uses the service provided to it and by the physical layer. Physical layer accepts the raw bit stream only, and it delivers it to the destination. This bit stream may contain error. So that is number of bits received may not be equal to number of bits transmitted. The data link layer breaks the stream into discrete frames and computes the checksum for each frame. At the destination, the checksum is recomputed. The breaking of bit stream by inserting spaces or time gaps is called as framing. So since it is difficult to risky to count on timing and mark the start and the end of each frame. So in this framing we are having two types. So one is fixed size framing. So in fixed size framing, the framing can be of fixed or variable size. So in this there is no need for defining the boundaries of the frames. So the size itself can be used as a delimiter. So delimiter means with this best example is ATM machine. So ATM is the best example for fixed size framing. So next one we are going for a variable size framing. In variable size framing, end of the frame and then beginning of the next frame is defined. So it will be defined by two methods. So one is character oriented and then second one is bit oriented. మన కథ తయ్యా அவ கூட இரு அவன் வரப்போறான். So next one we are going for a byte stuffing and byte oriented protocol. So in byte oriented protocol, data to be carried or 8-bit characters from a coding system such as ASCII codes. So header contains source and then destination address, and other control information are also multiple of 8 bits only we are using here. Trailer contains error detection or error correction, that is called as redundant bits are also multiplies of 8 bits. So in this diagram it will shows the character oriented protocol. So in this character oriented protocol, we are going to separate one frame from the next, and then 8-bit flag is added at the beginning and the end of the frame. So the flag consists of protocol dependent special characteristics and then signals the start or end of the frame. So character oriented framing was suitable only for text data transmission. So the flag could be selected and any character not used for text communication also. When we send other types of information such as graph, audio and video, the flag should also be part of the information. So it creates problem for receiver. When receiver encounters this pattern in the middle of the data, it thinks that the data will be reached the end of the frame. To solve this, we are going for a byte stuffing. So in this diagram, we are using a byte stuffing concept. So a special byte is added to the data section to the frame where there is a character with the same pattern as flag. So here, see here, we are using a flag here. So this only we are going to add it in a byte stuffing concept only. So the data section is stuffed with an extra byte. So this byte is usually called the escape character, which has a predefined bit pattern. So it shows byte stuffing. Whenever the receiver encounters the escape character, it removes it from the data section and treats the next character as a data, not a delimiting flag, so that it is very useful. So byte stuffing is a very important thing. So if the escape character is a part of the text and extra one is added to show that the second part is part of the text only. So escape is used for anywhere we can able to use it. And the next thing, we are going for a bit oriented protocol and bit stuffing. So in this protocol, the data section of a frame is a sequencing of bits to be interpreted by a upper layer as text, graphic, audio and video. So we have faced some disadvantage in byte stuffing and character oriented protocol. So what is the disadvantage there? We can't able to include a text, video and then audio, so that we are moving for a bit oriented protocol. So in this bit oriented protocol, we can able to interpret a graphic, audio and video also. So most protocols use a special 8-bit pattern, that is flag is 0, 11 11 11 10 as a delimiter means to define the beginning at the end of the frame. So in bit stuffing, a specific bit is stuffed into the outgoing character stream. The format that can be the data will be, we are going to add it here. So this is the original data was 0110, and then we are having a 8 plus 16 ones and then 0010. So after that, after consecutive of 5 ones, we are adding a 0 here. So see this, in question we are having a 0 and then 1 1 0. So here we are having a 5 consecutive ones, 1 2 3 4 5. So after 5 consecutive ones, we are adding a 0 here. So and then next 5 consecutive ones, we are adding a 0 here. And then after 5 consecutive ones, we are adding a 0 here. So this is called as a stuffed bits. After adding the 0, we are going to send the original data to the receiver. So in bit stuffing, the original data and then the data as they appear on the line, and then the data as they are stored in receiver memory after destuffing. So this is the concept we are using in a bit stuffing. So each frame begins and end with a special bit pattern. So that is called as a flag byte. So when 5 consecutive ones are encountered in the data, it automatically stuffs a 0 bit into outgoing bit stream. So this is called as a bit stuffing. And the next thing we are going to see here is a framing in a data link layer also presents some challenges. So what are the challenges we are facing here? So in variable frame length, we are facing some problem here. So that we are going for a HDLC and PPP. PPP means point to point. So variable size framing, we have seen two methods. One is character oriented and then another one is bit oriented. So we are facing some disadvantage in that carrier oriented and bit oriented, so that we are moved into a byte stuffing. So and then in the second one, bit stuffing. So this is a technique used to prevent data from being interpreted as control characteristics. And then we can see the issues in synchronization, as well as we are having some overhead of transmission also. And the next part, we are going for a synchronization. So it is a critical that we can't able to ensure the data frames that is transmitted and received correctly. So that it is also a very high speed network one. And then next one is error detection. So in error detection we are using a checksum and CRC concept. And the next one, efficiency. To find out the efficiency we are using a bandwidth only, and then in this we are going to associate it with the frame, and the error detection can reduce the overall efficiency of the transmission. So in overall, in this part we have seen the introduction of data link layer. So in this part we have covered, so what is a data link layer, and then what are the issues we have faced in a data link layer. So something that is the function of data link layer include well defined service interface to the network layer. That is first thing we have seen framing, and the next one we have seen flow control, and then error detection, error control, and frame formatting and sequencing we have seen here. So first thing framing means point to point connection, and then next one we have seen a error detection, that is identifying the errors. So error detection is plays a vital role in designing data link layer. And then we have seen error control, and then error detection and retransmission will be occurred here. And the next one we have seen the frame formatting. So in this frame formatting, both source and destination address will be declared. And then in sequencing, the order of updates to the to ensure the successful and unsuccessful message is called as a sequencing. And then next we have seen the what are the service provided to the network layer. So in this we have seen three services. First thing is unacknowledged connectionless service, second one is acknowledged connection service, and then third one is acknowledged connection service. So after that we are moving to the framing. So in framing, so we are going to get the service in by the physical layer only, right? So in physical layer we are having some disadvantage, so that we are going for a data link layer. So what is the disadvantage we are faced in a physical layer means, physical layer accept the raw bit stream and deliver it to the destination. This bit stream may contain error, so number of bits received may not equal to the number of bits transmitted. And then at the end, on the destination we are going to receive the same address. So the in data link layer it will be breaks the stream into discrete frames and compute the checksum for each frame. At the destination the checksum is recomputed. The breaking of bit stream by inserting spaces or time gaps is called as a framing here. So and then in this we have seen fixed size framing and then variable size framing. So in fixed size framing, there is we have seen the example of ATM machine, and then in variable size framing we have seen the two types, that is two method. One is character oriented and then bit oriented. So in character oriented we are going to add a header and trailer concept, and then we are going to add a flag also here. So what is mean by flag? So flag means a special character signal to start the end of the frame. It is suitable for only a text data transmission. So when we send other types of information such as graphs, audios and video, flag could also be the part of information. So it creates problem for receiver, and receiver encounter this pattern in the middle of data, thinks it has reached the end of the frame. To solve this problem only we are going for a byte stuffing. So in byte stuffing we are going to see a special byte is added to the frame data section. So that is escape character. So the data section is stuffed with the extra byte. It is called as a escape character. So after that we are going to see a bit oriented protocol. So in bit oriented protocol we have seen after 5 consecutive ones we are inserting a 0. So in next topic we are going to see is a correction and error detection. So in this error control, to ensure the proper sequencing and safe delivery of frame at the destination, and acknowledgement should be sent by the destination network. And then in flow control we are going to see when the sender is running on a fast machine or lightly loaded machine, and receiver is on slow or heavily loaded machine, so then the transmitter will transmit frames faster than the receiver can accept them. So even if the transmission is error free at a certain point, the receiver will simply not be able to handle the frames as they arrive and will start to lose something. so that only we are going for a error control. So in this we have seen that three types, that is damaged frame, lost frame, and then lost acknowledgement. So that by the use of this only we can able to overcome those challenges.